Hello guys, in this video I will be explaining about how to find infinite limits. So let me introduce you what infinite limit is. The idea is a function is moving in a particular direction but heading off to a horizon, either going up or down as you approach to a fixed number. We call infinite limit as unbounded limit as well. Because we call this as infinite or unbounded limit, the result of the limit becomes infinity. How so? For example, you have a function like limit as x approaches to c of a rational function, let's say f of x divided by g of x. By substituting c for x, you get number divided by 0. So number other than 0 divided by 0 gives you infinity. So whenever we have this situation, by substituting the value of x in the function in limits, we get number over 0 condition, then the answer is going to be infinity. But keep in mind that infinity is just a symbol. It doesn't represent a real number. So since it is not a value, it's not a real number, these cases will give us uh, limit does not exist. So whenever you have this condition, the answer to the limit question is infinity, then we basically say limit does not exist. So this is one of the cases that limit does not exist. We use this infinity to describe unbounded conditions. So we are not using this to determine the value. It's not a value. It is just describing the behavior of the function, describing the unbounded condition. All right. So it doesn't tell us limit exists. On the contrary, it tells you how the limit fails to exist. It's one of the cases that limit does not exist. All right. So let's take a look at this situation graphically to make more sense. Let's say this is your function. This is your inverse function, 3 over x minus 2. The question is, let's say, for example, the question is telling you to find the limit. Find limit as x approaches to 2 of f of x. In this case, we will substitute 2 for x. Limits as x approaches to 2 of 3 over 2 minus 2, 3 over 0. So we will say there is infinity. So limit does not exist. So in options, three options will have numbers. One option will have does not exist. So this is the answer to your question. If the question is asking about limit at a fixed number and you have number over 0 condition. But if question asks one-sided limit, let's say the question asks you to find limit as x approaches to 2 from left of f of x, and it asks you to find limit as x approaches to 2 from right of f of x. If it is asking about one-sided limit, your options will not have does not exist. Your two options will have numbers, the other two options will have negative infinity, positive infinity. So for these kind of questions, if one-sided limit is asked, then your answer would be negative or positive infinity. You are asked to give the direction of infinity. Okay. So how do you find whether you have negative or positive infinity? If the graph is given, it's very easy. Let me show you on the graph. In this question, graph is given. So let's remember how to check our one-sided limit. From left, remember, this is number 2. As you approach 2 from the left, look at the behavior of your graph. Your graph is heading down towards negative infinity. As you approach 2 from the left, your graph is going unbounded towards negative infinity. So the answer to this question is negative infinity. All right. Um, Similarly, check right-sided limit. When you approach 2 from the right, what is your graph doing? There's no graph on below on the right side of 2, but there's graph above on the right side of 2, which is going up unbounded towards positive infinity. So the right part of this graph is going up unbounded towards positive infinity. So the answer to this question is positive infinity. All right. So you will face two types of questions. Either asking about the limits at a fixed point. The answer would be does not exist if you have number over zero condition. Or the question will ask you one-sided limits. So depending on the question, you'll either have negative or positive infinity when you have number over zero condition. So if the graph is given, you just look and tell the answer. It is pretty simple. But if the graph is not given, let me show you the way. If the graph is not given, what happens? How do you find? Let's take a look at this note. This note is useful for questions asked algebraically. If left-sided limit is asked, you will pick a value very smaller than we will pick a value smaller than c but very close to c. How do you determine how close the number to c is? You can always use a number 0.1 less than c and substitute it back in the function for x and identify the sign. Similarly, if right-sided limit is asked, you will pick a number bigger than c but very close to c. You can use a number 0.1 bigger than c and substitute it back in the function for x and determine the sign of the result. So according to the sign, you will say whether it's negative or positive infinity. All right. So in this question, how does it work? For example, by using this idea, 2 from the left, you pick a number very close to 2 but smaller than 2, or you use this c minus 0.1 rule, so you can subtract 0.1 from 2, it's gonna be 1.9. You'll substitute 1.9 back when x is 1.9. 3, top is positive, 0.9 minus 2 is 0.1, bottom is negative. So positive over negative will give you negative infinity. I don't care about the results. I am just using this number to identify the sign of infinity. Okay. Similarly, from positive side, this time you add 0.1 to the number that you're approaching. 2 plus 0.1, 2.1. So substitute 2.1 for x and see the sign of the result. 3 is positive. 2.1 minus 2 is 0.1, which is also positive. Positive divided by positive is positive. Okay, like this. Let's take a look at the first question. Let me clear this a bit. All right. For some questions, there are some questions that you know their graph, right? So you can use their graph. I always find using the graph easier. Um, Evaluate the limits as x approaches to 0 from the left of 1 over x and 0 from right of 1 over x. 1 over x is a very common graph. It's one of the parent functions. It's an inverse function. You know how it looks. The graph will look like this. So the question is, what is limits as x approaches 0 from the left of 1 over x? From the left, what's happening from the left? As x approaches 0 from the left, the function is getting unbounded in the negative direction. When you approach 0 from the left, the function is getting unbounded in the negative direction. So the answer to this question is negative infinity, right? Similarly, as x is getting closer and closer to 0 from the right, your function is getting unbounded in the positive direction. So this part, the right part of 0, is heading up unbounded towards positive infinity. So the answer to this question is positive infinity. So you can say this is the first way. If you know the graph, you apply the graph. If you can't think of it, you always have an algebraic way. How so? Like I explained in the notes, you pick a number very close to 0, but smaller than 0 for left-sided limit. For right-sided, bigger than 0. So for left-sided, it's going to be 0 minus 0.1, which is negative 0.9. From the right, 0 plus 0.1. From the left, you subtract 0.1 from 0. From the right, you add 0.1 to the number, 0.1. So you substitute those numbers for x in the function. So for the left side, limit as x approaches 0 from the left of 1 over, in place of x, you will write negative 0.9. So the sign of the top is positive, sign of the bottom is negative, positive over negative is negative. So this is the sign of the infinity, negative infinity. What about right-sided limit? For right, limit as x approaches to 0 from the right of 1 over, in place of x, this time you will insert 0.1. So the sign of the top is positive, sign of the bottom is also positive, so the sign of the result is positive. Then the sign of the infinity is positive infinity. All right? This is pretty simple when you know what to do, right? The following question. So we can use the same numbers because it's still 0 from the left. We can use negative 0.9, from the right, 0.1. So for the first one, limit as x approaches 0 from the left of negative 1 over negative 0.9 squared. The sign of the top is negative, sign of the bottom, no matter what I have inside, since I am squaring it, it's always positive. Negative over positive is negative, so negative is the direction of infinity. So the answer to the first part is negative infinity. Second part will be the opposite or the same. We don't know. We can't know. We should try. So similarly, you insert 0.140 from the right, 0.1 squared. So negative for the top, still positive for the bottom. So negative over positive, negative. So they are both heading towards negative infinity. So the answer to this question for both is negative infinity. So if you are curious about the graph, it's going to be something like that. Okay. Okay, let's move on. A similar question. This time it's asking about the limits if whether the limit exists. So we will either say exists, tell the answer, or does not exist if we have number over 0 condition. So let's take a look at the limit here. Limit as x approaches to 1 of 1 over. If I insert 1 back for x, it's going to be number over 0. So whenever you have number over 0 condition, you can directly say does not exist. The same goes for the previous questions. When you insert 0 for x, it's going to be negative 1 over 0. So limit does not exist, but we were looking for one-sided limit, so we solved the question. We didn't just stop. In the first question, we also solved the question because it wasn't asking about the limit at 0. If it were asking about limit at 0, we would say 1 over 0, number over 0 does not exist, but it was about one-sided limit, so we solved the question step by step. Here, we don't need to solve it. We can directly insert the value of x and see number over 0, so it does not exist. All right. Let's take a look at a test prep question. Limit as x approach to 2 from the left. So what do we do? From 2 from the left, what number should you use? You should use a number smaller than 2. How small? You just subtract 0.1 from 2. 2 minus 0.1, 1 minus 9. So insert 1 minus 9 for x. So it's going to be 1.9. 1.9 at the top. At the bottom, 1.9 minus 2. So the sign of 1.9 is positive. Sine of 1.9 minus 2 is negative 0.1, which is negative. So plus over minus is minus. So the direction of infinity is negative. Your answer would be negative infinity. All right. So the ministry questions are coming like this. Generally, they're asking one-sided limits. And questions are pretty simple like this. It's a ministry question, the next one. We use the same idea. 3 from the left. So we subtract 0.1 from 3. It's 2.9. So we insert 2.9 for the function. So 2 minus 2.9 divided by 2.9 minus 3. 2 minus 2.9, negative zero point 0.9 divided by 2.9 minus 3 is negative 0.1. So negative divided by negative will give you positive result. So if the result is positive, then my answer is positive infinity. See, it's pretty much simple. Another ministry question. All of the options are asking about one-sided limits and determine which one is true. The first option, 1 from the right. Pick a number from the right, like 1.1. If you insert the 1 from the right, you add 0.1 to the 1, so you use 1.1. 1.1. So negative is the sign in numerator. 1.1 minus 1 is 0.1, which is positive. So negative divided by positive is negative infinity. First option is true. Second option, 1. The sign of the numerator is positive. 1.1 minus 1, 0.1, whose sign is also positive. Positive over positive is supposed to be positive infinity. So that's false. Option C, 1.1. Negative is the sign of numerator. 1.1 minus 1 squared, since I am squaring it, no matter what I have inside, it's going to be positive. Negative over positive is supposed to be negative infinity, not positive. So it's also false. Last option, 1. The sign is positive. 1.1 minus 1 squared. Squared, it's also positive. Plus plus makes plus positive infinity, not negative. It's also wrong. So my correct answer is A. All right. One last question and we will finish the lesson. Use the given graph below. Which one is false? So one by one. Limit as x approaches to negative 2. Negative 2. The graph is not broken. There's no jump from the left or from the right. The function is tending to the same number, which is 0. So the y value at this point is 0. It's true. What about limit at 2? At 2. From the right, the graph is going unbounded in positive direction. from the left of 2, graph is also going unbounded in positive direction. So from both sides, the graph is heading up infinitely. So if there is infinite limit, then limit does not exist. It's also true. What about 0 from the right? This is 0. From the right, I don't have graph above on 0. Below I do. From the right, my function is heading towards to this point, whose y value is negative 2. So that's also true. Last one, 1 from the left. 1 from the left. This is 1. There is a broken graph here. The right side is going up. On the right side is this, left side is this. I am looking for left-sided graph. The left part is this. So at 1, the left side of the graph is tending to this point, whose y value is negative 1, not 1. So this is false. All right. So we are done with this topic.